All right. Okay, so you have this rational expression. Let's say we had this. 3x plus 7 divided by 6. Suppose I had this rational expression. Remember, this is a rational expression. Soon, in one of the sections in this chapter, we're going to look at rational equations. Do you see an equal sign here? So it's just a rational expression, not an equation. An expression. Just like when we dealt with factoring, the polynomials, one was just a polynomial, and then all of a sudden became an equation, a quadratic equation, so to speak. Okay, so for what values of x is this rational expression undefined?
One is equal to 0.
What now?
Denominator is equal to 0.
Okay, so your rational expression undefined with the denominator is 0. So what values of x is this rational expression undefined? So what do you do when you have a rational expression? You want to find out where it's undefined. What did y'all do in that worksheet that some of you turned it in? Put what equal to 0? The denominator. What's my denominator here? 6. So what's getting you is the fact that you don't see a variable down there, right? That's why you're not sure what to do. Well, it's just kind of like when we solved the equation where you had that 3 and you said that equal to 0. Did it make any sense? No. So you look at this denominator. Does my denominator contain a variable? No. So is it ever undefined? A rational expression undefined when the denominator is what? My denominator is always going to be what? 6. It's never going to be 0. So are there any numbers for x where my rational expression here is going to be undefined? No. So there are no values for x for which the rational expression is undefined. So in my math lab, there is one where the denominator is just a constant. There's no variable there. So just keep that in mind. So there's none, okay? All right, now let's look at this. So now we're going to simplify rational expressions. So we started talking about that last class period. So that's where you factor the numerator and factor the denominator, and then you reduce the common factors. Remember that? All right, so suppose we had this. This is going to be number 36. And this is on page 1039. And this is section 14.1. Okay, so you have 9x plus 99 divided by x squared plus 11x. And you want to simplify this. So what kind of expression is this? No. What kind of expression is this? Rational expression. You have a polynomial divided by a polynomial. That's a rational expression. And you want to simplify this. And to simplify, remember, you're going to reduce out your common factors. That's how you simplify. You reduce your common factors. Well, in here, right, in this these words I just wrote is the word factor. So what do you think you need to do to the numerator and denominator? Factor. So you got to factor first. So you have to factor first. So how do you factor the numerator? So the GCF is 9, so that's 9 times x plus 11. What about the denominator? So x times x plus 11. So once you factor, so to simplify, the first thing you do is factor. So step 1 is to factor. And then step 2 is to reduce your common factors. So you divide out your common factors. So in the numerator, what's the first factor listed in the numerator? 9. Will 9 reduce with any factor in the denominator? No. What's the next factor listed in the numerator? X plus 11, not x, x plus 11. Is there an x plus 11 occurring anywhere in the denominator? Yes, so I can reduce that. Now remember, when I reduce it like this, just like we talked about before, if I have 20 divided by 25, you agree that's 5 times 4 and then 5 times 5? And when I reduce this, you just don't cross it out like this. What's actually in their places? 1s. So when I cross this out, what really goes here? What I'm left with is a factor of 1, right? And 9 times 1 is 9. X times 1 is x. So there's your answer. So number 36, when simplified, is just 9 divided by x. So the first thing you do when simplifying rational expressions is to factor, and then you reduce your common factors. Okay? All right, 38. 38. All right, 38, you have x minus 3 divided by x squared minus 6x plus 9. All right, so remember, in order to do this chapter, you have to remember the previous chapter, so you have to know how to factor. Okay, what kind of expression is this? Rational. What do you want to do with it? No. What does the direction say?
Simplify.
Simplify. So to simplify a rational expression, you just remember how you simplified rational numbers, fractions. You look for common factors. So the first thing you do is factor. How do you factor the numerator?
By putting them in normal, what is it called?
Hmm?
The factoring of them to simplify it. I don't know. I think they call binomials or the two parentheses.
You can't, but that's not quadratic. It's x minus 3.
Oh, I'm talking about the denominator.
No, I said the numerator. How do you factor the numerator? You can't, right? How do you factor the denominator? Well, first of all, you always look for a GCF. Okay, it's 1, so then you go to the two binomials. So the numerator is going to stay x minus 3. Now let's talk about the denominator. What's the denominator? X minus 3 times what? X minus 3. So you see, at this point, now notice how quickly we did that, and that's what you're supposed to do. At this point, you're supposed to be a little bit more and more efficient with factoring, because as you've been doing it since the first week of school, or the second week. So you got to become efficient. Don't spend the same number of time you did a month ago on factoring now. You're supposed to be quicker with it. All right, because there's a lot more things you're doing now. Now they're rational expressions, and you have to do more with it. You have to simplify. It's not just factoring now. There's more things. So that part you need to be proficient now. Now what do you do? Reduce your common factors. Okay, in the numerator, how many factors do you see? 1. What is it? X minus 3. Are there any x minus 3s in the denominator?
Yes.
So I can reduce. How many are there in the denominator?
2.
I can only reduce how many? 1. So you cross one of them out. It doesn't matter which one. What goes in their place, though? Because see, if you don't put what factor stays there, you're going to say the answer is x minus 3, and it's not x minus 3. The answer is not x minus 3. It's 1 over x minus 3. That's why you got to put those 1s there. So the numerator is a 1, and the denominator is 1 times x minus 3, which is x minus 3. So there's your answer. So number 38 simplified is 1 divided by x minus 3. So it's not a difficult section. As long as you know how to factor, you can do this. All right, 46. 46. You have 2x squared plus 7x minus 4 divided by x squared plus 3x minus 4. Oops. So 2x squared plus 7x minus 4 divided by x squared plus 3x minus 4. Now, mistake people make, because they're not thinking, they're not understanding what they have to do here. What some people do is they'll cross out these x squares, and they'll cross out these x's and these negative 4s. You can't do that. You can only factor out factors, and factors separated by product symbol. So that's not what you have here. 2x squared is not a factor because of that plus symbol. So what do you just got to do first before you start crossing things out? Factor. All right, now the GCF on both of those is what? 1. So go directly to the two binomials in both cases. All right, what about the numerator? What is that? X and 2x, right? Yeah. Now, you have a 4 there. Do you think you use a 4 and 1 or 2 and 2? 4 and 1. You're not going to use 2 and 2, right? You know 2 and 2 is not going to work because for the reason that if you put a 2 here, that means you can do a what here? You can take out a 2, which means this whole thing was divisible by 2, and is it? No. So it has to be a 4 and a 1, and where do you put the 4? Here, and the 1 goes here. So remember, that's all part of that previous chapter. Okay, last sign's negative, so the signs are different. So that means that the 4 has to be what? Plus. The 1 has to be negative. Because you want a 7x. The only way we can get a 7x is for 4 times 2x to be a positive 8x. And x times 1 is a negative 1. That's where we get that positive 7x. What about the denominator? XX. Now, usually what's going to happen, remember, you're simplifying rational expressions, correct? Mm-hmm. So usually what's going to happen is that it's going to be simplified somehow. So one of your factors better show up in the denominator. So don't all of a sudden say x minus 4 and 2x plus 1, because nothing divides out. So it's always in such a way to where something does divide out. So XX, 4 and 1 again. Well, you see that 4, right? So what do you think this is going to be? A plus. So put it there and put this at what? Negative, but check. What's the outer? Negative x. The inner? 4x. So I get that 3x. Yeah. All right. Now, what do you notice? The x plus 4 is divided out. What do I put in their places? 1s. And that's all, right? So what's the answer? X minus 1. So there's your answer. Can't do anything else to that. Nothing else can be simplified. All right. 54. All right, 54, you have x squared minus 16 divided by x squared minus 8x plus 16. And so I want to simplify this rational expression. Can I cancel out these x squareds? No, you cannot do that. You cannot do that. You cannot do this. This is wrong. You can only factor out, you can only reduce factors. X squared is not a factor. So what's the first thing you've got to do, though? Factor by first finding the GCF, which is 1 in both cases. So what do you notice about the numerator, though? So what? Difference of 2 squares. So I can factor the numerator as x minus 4, x plus 4. All right, the denominator. So hopefully, see, one of those factors better show up down there. Because we're reducing, and usually when we reduce, when we simplify, there's a common factor. Okay, so x minus 4, right? So x minus 4 times x minus 4. And what do you notice? You have a common factor. The x minus 4s. I'm going to do one of them, though. So what's the answer? All right, so that's 54. Okay, 56. You have AB plus AC plus B squared, that's an AC right here, plus B squared plus BC divided by B plus C. So AB plus AC plus B squared plus BC divided by B plus C. So on your study guide for the test that's coming up, what do you, and you're going to have this, what do you notice about the numerator? How are you going to do that? Huh? The GCF is 1, so what are you going to do next?
Oh, you're gonna group.
Grouping.
Oh,
You had that on your first test, you have it again in your second test. So grouping, right? You have 4 terms. How many terms do you have? 4. So let's go off to the side. I'm going off to the side, and I'm going to factor using grouping. So I'm going to rewrite the numerator. All right, in the first group, what can I factor out? A. And you're left with A times what?
B plus C.
B plus C. Now remember the middle sign, so I'm going to factor out a positive here. So I'm going to factor out positive what?
B.
B, and I'm left with what?
B plus C.
B plus C. So when I factor the numerator, what's my factor now?
A plus B times B plus C.
Times B plus C. Y'all agree? Okay, that's the numerator. So A plus B times B plus C divided by what? And now you notice, what can you do? Factor out the B plus C's, so what's the answer?
A plus B.
A plus B. Okay? So A plus B over 1, don't leave it as divided by 1 because you know anything divided by 1 is that numerator. So leave it as A plus B. So on test number 2, if you look at the study guide, there's one in there about the grouping from the old material. All right, 60. Okay, 60. So remember, in order to be able to do this chapter, you have to know how to factor. All right, 60, you have 2xy plus 2x minus 3y minus 3 divided by 2xy plus 4x minus 3y minus 6. Okay, both cases you're going to have to use what? Grouping. And I think the GCF in both of them is 1, right? Yeah. So let's group the first 2 the last 2. So here's my numerator. In the numerator, in the first group, what can I factor out? 2x. Okay, good. 2x. 2x times what?
Y plus 1.
Y plus 1. Not just y plus 1. In the second group, what could I factor out? Negative. Okay, negative 3. You got to take out that middle sign. And what do you get?
1 minus.
No.
Oh, right.
You know, it cannot be y minus 1. Cannot be that because these have to be the same. And then think why it cannot be, because what's a negative times a negative? And you wanted a negative 3. So what should this be? Y plus 1. Okay? And so you get y plus 1 times what? 2x minus 3. So that's the numerator. All right, so that's the numerator. Okay, now the denominator, let's do that one. From the first group, what can I take out? 2x again. What are you left with? y plus 2. Okay. In the second group, what can you take out? What are you left with it? Y plus 2. Those two things in parentheses better be the same. And so what do I get when I factor the denominator? Okay, y plus 2 times 2x minus 3. So that's your numerator. So y plus 2 times 2x minus 3. Okay, now what can I do? Divide out the common factors. So which ones can I divide out? 2x minus 3. Don't just cross these out. Put a 1s in their place because that's what factor is really left there. And don't you see how the only factor left in the numerator is y plus 1? Don't put that in parentheses. Just put y plus 1. And the denominator is going to write what? Y plus 2. So that's your answer. So all you're doing is just factoring. That's all you're doing. Okay? All right, now, let's look at this. Okay, let's kind of review something for a moment. 8 and negative 8, remember, are called opposites. Okay? And so if I find the quotient, remember quotient means to do what? Divide. So if I take those two numbers and divide them, and remember they're opposites, right? What number do I get? No. Negative 1. Negative 1. When you add them, you get 0. When you divide them, you get negative 1. Okay? So I want you to notice this, though, that when I reduce, if I were to go ahead and do the idea of reducing here, 8 into 8 is 1. 8 to negative 8 is negative 1 as well, right? So I get 1 divided by negative 1 is what? Negative 1. Also keep in mind that I could have, instead of just saying 8 divided by negative 8, I could have said negative 8 divided by 8, which would still give me what? Negative 1. All right, so when you're dealing with opposites, whenever you reduce opposites, what factor is left? Negative 1. Okay? All right, keep that in mind. So, look at this for a moment. Simplify. X minus 2 divided by 2 minus x. So before this point, things are fairly easy. All you did was factor, cannot be nice, and you're done. But then you get into a point where you're looking at this and you're saying, well, I can't factor x minus 2 because the GCF is 1. And then 2 minus x, the GCF is still 1, right? Okay? But what do you notice about x minus 2 and 2 minus x? All right, so in other words, here you have positive x, here you have what? Negative x. Here you have negative 2, here you have positive 2. So those two binomials are opposites of each other. They're opposites. X minus 2 and 2 minus x are opposites. So if I had this, if I had 3x plus 5, what would be its opposite? And all you do, guys, all you do is just change the signs. So you could say negative 5 minus 3x, or you could have just said what? Negative 3x minus 5. So with numbers, it's easy. 10 and what are opposites? Negative 10. With polynomials, all you're doing is, in order for them to be opposites, the signs have to be different. 3x, negative 3x, positive 5, negative 5. What's the opposite of x squared minus 3x is what? Negative x squared plus 3x, or you could have just said 3x minus x squared. Same thing, right? Does not matter. So notice all in terms of opposites, the signs of the terms are different. It's just the signs. So when you're simplifying and you have opposite factors, when you're simplifying and you have opposite factors, like going back over here, are those opposites? Yes. All you need to do the quickest way, and we're going to see why it's true, but the quickest way is that since these are opposites, since we notice those are opposites, then do this. You know they're going to reduce. Opposites are going to reduce and give you what number? The quotient's -1, right? Okay, -1. So here's what you do. Make this -1 and make this a +1. So we tend to make the numerator a -1 and the denominator a +1, and you're left with what? -1. Now it did not matter. It did not matter. You could have done this. Cross them out. This becomes a 1. This becomes a -1. And you're left with -1. Now let's see why this is true. All right. Listen carefully. Do you remember in the first section we talked about when we did factoring, one of the things they asked you to do was to factor out a -1? Yeah. Remember that? Okay. So let's factor out the -1 from the denominator. If I factor out the -1 from the denominator, -1 times what is a +2? -2, right? -1 times what's a -x? +x. Now, what do you notice about these two factors right here? No. These two factors right here, x minus 2 and -2 plus x, they're the same. Isn't x minus 2 the same as -2 plus x? So when I divide them out, what's left in their places? 1s. So what's the numerator? What's the denominator? And that's what we had here, 1 divided by -1. So the reason why you can just cross them out and put 1 and -1 is because one of the things you learned in the other chapter was you can factor out a -1. Remember, that's one of the things you were asked to do at some point was factor by taking out the -1. Okay? All right, so let's see how this is going to work now. So let's look at this. So now you're going to start being aware of opposites now. Opposites. Okay, this is 26. You have y minus 9 over 9 minus y. So you want to simplify this rational expression. The GCF in both cases are 1s, and you may say, well, there's nothing I can do. Well, that's true at this point, but now you know about what? Opposites. Are those opposites? Yeah. Yes, those are opposites. Y minus 9 and 9 minus y are opposites. And you can easily see that they're opposites because the signs are different for each term. Y, -9, +9. They're opposites. So the quickest way to do this is just do this. When you divide them out, when you divide your common factors, you cross them out, make one factor a +1 and the other factor a -1. It does not matter which one you use. 1, -1. But what's 1 divided by -1? -1. Now again, make sure you understand why this is true. And it goes back to a previous chapter. I can factor out a -1 from either one of those, does not matter. So I want you to notice this. If I factor out the -1 from the numerator, -1 times what's a +y? -y. -1 times what's a -9? +9. And in the denominator I have this. What do you notice about these two that I'm circling right here? They're the same. So when I divide them out, they're both 1s. And what's -1 times 1? 1. And what's -1 divided by 1? 1. I could have factored out the negative 1 from the denominator. It did not matter. If I factor out the negative 1 from the denominator, what's left? Negative 1 times what's a positive 9? Negative 1 times what is a negative y? What do you notice about those two factors I have circled? They're the same, so when I divide them out, the 1's in their place. But I still am left with what quotient? Negative 1. Okay, so that's why the opposites like that work. It has to do with a previous chapter where you factor out the negative 1 and you're left with negative 1 as the quotient. Okay, and let's look at this one. So this is going to be trying to find one with on my math lab there are quite a few opposites. Okay, so let's look at 52 for a moment. Now, when I go over 52, I'm going to say something about what I noticed on the worksheet that some of you did with this. Okay, so on the worksheet, you may have had something like, well, let's do 49 minus y squared. What some of you said that this was y minus 7 times y plus 7. That's not true. That is not y plus 7 times y minus 7. So that worksheet you turned in on one of them, and there were a few of you that did this, a couple of you I should say. Don't say this is 7 plus, I'm sorry, y plus 7 times y minus 7. That's not true. When you factor this, difference of two squares, what goes here? 7. What goes here? Y. So this is 7 minus y times what? 7 plus y. So that's your numerator. Okay? And what's the denominator? All right, so that's where we're at. So the first thing you do is factor. So I've factored. Now, what's the first factor listed in the numerator? 7 minus y. Do you see 7 minus y exactly occurring in the denominator? No. But what do you notice? Its opposite is there. Its opposite is there. So that means that I can divide these. Now, it's usually best, see how you have a factor left over right here? It's usually best to put the negative 1 in the numerator. So this is going to be a negative 1, this is going to be a what? Positive 1. And then all you do is, now in my math lab, if you left it as negative 1 times 7 plus y, that's fine. That's your answer. Because the number is just 1, right? So anything divided by 1 is that numerator. So you're done. That's your answer. Now, if you went ahead and distributed, that's fine as well. So you could have said what? If you distribute, you could have said what is the answer? Negative 7 minus what?
So why did you put the negative 1 on the top rather than the bottom?
Okay, so remember a while ago we said it did not matter where you put the negative 1?
Right.
But since there was another factor in the numerator, it's usually easy, you're going to see that as you go through this, it's usually easy to put the negative 1 in the numerator and the positive 1 in the denominator. Okay, and then in this case, there's only one number then there, it's just 1. So if you wrote it as 7 plus y divided by negative 1, that's not how we tend to write it mathematically. We tend to put that negative 1 in the numerator. So that's why it's always easiest to factor it like this, where this is negative 1, this is positive 1. So you'll notice that in all the problems we're going to do where there are opposites, I'll make the numerator negative, the denominator positive 1. That's why I'm going to do it. Okay? All right, so let's look at this one. Suppose you had all right, suppose you had this. Suppose you had, and write this example. Simplify. And watch how simple this is, not that difficult. 2x squared minus 5x minus 12 divided by 16 minus x squared. So 2x squared minus 5x minus 12 divided by 16 minus x squared. All right, the g-set for the numerator is 1, so you do the two binomials. So what are you going to write? Oh, it's not going to be 2x minus 4, because you know why, right? Right away you should have known why, because you could have taken out a 2. And the g-set is not a 2. So it can't be 2x minus 4, so maybe 2x minus 3 possibly? And then x plus 4? But does that work? No. Now we're almost there. It shouldn't be 2x minus 3, it should be what? Plus 3. And then x what? Minus 4. And that should work because what's the outer now? Negative 8x. The inner is a positive 3x. When I add them up, do I get that negative 5x? Yeah. Now what about the denominator? How do I factor that? Is it x minus 4 times x plus 4?
4 minus x, 4 plus x.
All right. Right. So it is not x minus 4, right? It is 4 minus x. So 4 minus x, 4 plus x? Okay. All right. So that's where I'm at. Can I reduce anything?
Yes.
What can I reduce?
X minus 4 and 4 minus
All right. So these two right here are opposites. So I'm going to cross these out. I'm going to put the negative 1 here and the positive 1 here. And so my numerator then would just be negative 1 times 2x plus 3 over what? X plus 4. Or you could have just said what? 4 plus x. Doesn't matter. But do you understand that 4 plus x is the same as x plus 4? Okay. That's one way to write it. That's one way to write it. So I'm going to list all the possible scenarios that you could see. You could have also done this. Make sure you understand that that's the same thing as what we had above. Instead of writing negative 1, I could have just done this because that's understood to be what? Negative 1. Okay? I could have also done this. I could have distributed. So I could have said the answer is negative 2x what? Minus 3 over x plus 4. Okay? Could have done that. I could have put the negative 1 in the denominator if I wanted to. So in other words, when I had this right here, make sure you see all the different possibilities. So I could have done this and put this a 1 and this a what? Negative 1. And I could have said, all right, I'm going to write the answer as 2x plus 3 divided by negative 1 times what? 4 plus x or x plus 4. It does not matter. See, all these are correct. All these are correct. You could have also done this. I want you to remember something. If I have negative 3 divided by 4, do y'all agree that's the same thing as saying 3 divided by negative 4? Okay. Do y'all agree it's also the same thing as saying negative 3/4 like this? Okay. So when I wrote this right here, do y'all agree I could have also written this 2x plus 3 over x plus 4 with a negative out front? Same thing here. See this? So instead of putting the negative in the numerator, I could have put the negative outside the fraction. Yeah. Yeah, so these are all possibilities. So if my math lab gives you multiple choice and they have this, that's correct. If they have this, that's correct. And so what? Okay? All those are correct. So make sure you understand that this is correct because you know that you know about these. These are all the same thing. All right? Okay. But look for opposites now. Look for opposites. All right? Any questions at this point? Or you were saying until 10 o'clock.
My brother had anxiety attack, so that's why I'm late.
You had a what?
My brother had anxiety attack.
Okay. All right. Any questions at this point? You can do this, right? Okay. So let me just kind of show you what the worksheets look like. So I gave you part A already. So this is what part B looks like. All right. So you have your, and there's a, let's see, there's a back part. This is part B. All right, so it's just the front, so there's just 5 here. So you want to simplify this, so the first thing you're going to do in each one is what? Factor. Now, you're also going to have opposites here, because I'm looking at 2 minus x, and so that's going to be an opposite somewhere in here. So you have opposites involved, so this involves opposite as well. Let's say show the work. So make sure you show the work. Make sure you follow the directions. All right, so that's part B. Part C, same thing. Part C is just more practice, that's all it is. See, more practice, that's all it is. Except now sometimes you can fact there's a GCF other than 1. Here, the GCF looks like they were all, no, I was going to say all 1, but that's not true. Because what's the GCF in the numerator here? 5V, right? All right, but here it's just more practice. Look for opposites as well. There's, oh, the part B did not have grouping. This one has grouping. Okay, so we talked about grouping. And then, so that's part C. And then D, difference of 2, well, you can factor out of 5, and there's a difference of 2 squares. So you have difference of 2 squares. Oops, okay, now you have what here? Sum of 2 cubes. So the numerator is going to be grouping, right? The denominator is going to be the sum of 2 cubes. Now there's 1 or 2 of you that still have issues factoring sum of 2 cubes, difference of 2 cubes. The rest of you are fine with it, but you make sure if you still have trouble, you know how to deal with it on the test. All right, opposites, so there's going to be an opposite here. And you see opposite here as well, 81 minus x squared. So that's going to have an opposite, that's going to have an opposite. Okay? All right, so we go ahead and let you start practicing this. Now what we're going to do Thursday is we're going to start looking at multiplying and dividing these things. All right, so you have to know how to simplify these before you can do the next section. So I need you to be able to do the next section. So you need to start working on this. All right, so let me give these out. So this is going to be part B. Here's part B. Next one, pass the rest back. Yeah, a week from today. Here's part C. This Thursday we're doing multiplying, dividing. Now, we're not going to spend a lot of time on that because it just involves factoring. Oh, where's the rest of this? Oh, here we go. All right, so start working on this so you can do this now. And don't forget, your test is Tuesday, so you need to come as soon as you can to start taking it. All right, now here's the key to 13.6, Part B.